I'm so smart. Yeah, I'm so smart. Let's go. I'm beyond smart. I think I got one. Let's go. At first I was like, what? I got that one. I got one wrong. That's so pretty good. I got 1, 2, 3, 4 right. I got 4 right. Wait, wait, 5.
But
There's a notification on your phone, so it stopped recording.
Oh, low battery, please.
No problem. No.
That's sad. Rip.
It'll be okay. We'll see how far we can get. Okay, any of these you'd like me to do because you got the wrong answer, didn't understand it? Yes, Craig?
How's 1700?
Okay, what do you think it is?
2.
I think
Okay.
it's 2 2, guys.
2 times 5. Yeah, there's 15. There's only 15.
But it's green.
Greg, it's not that
Oh,
serious, bro.
shoot.
It's not that
I
serious.
forgot about 15. I forgot 15 could be divided by 5.
Well, what did you use?
I just used 15. I forgot that 15 could be divided by 3.
Oh, okay.
That makes sense.
I did 10 and 20. That's still not the same answer.
You can do that, yeah. Oh, okay. Okay, so then we've got a 2 in common. And we've got a 5 in common. That's why I get the 10.
Oh, I forgot to multiply. Oopsies. That wasn't very smart of me. I forgot to multiply. I was kind of tired. I just looked at it. I saw 2 is the most number.
Mhm. 1, 3, and 5 were okay?
Yeah.
Yeah.
That was easy.
Okay, any questions on the homework? No? Okay, so today we have paper notes. So I need you to come back and get a set of notes.
I'm trying not to use
Completely amazing person. Casey already did.
He didn't.
So did, what's his name, Damian Lillard? He had a gun in his head. Gun to his head.
Dwayne Wade lived down the
Better full position.
Damian Lillard was really.
Okay, so today our learning target on the board, I can factor expressions. You will also see on Friday is going to be our topic 4 quiz number 2. Okay, what is happening on Thursday? If you have to do the retake, and when is that happening? During break time. What do you need to have done before then? Brooke? The packet. So either today, tomorrow, or Wednesday, I need to see the packet so I can look at it and talk to you about it. And then on Thursday during your break time will be the quiz retake. And then on Friday will be quiz number 2. So that'll be over distributive property, greatest common factor, and then factoring expressions. Okay, so we're going to do 3 days of factoring expressions. We're going to have a review day on Thursday, and then your test or your quiz will be on Friday. And then we're done with this topic. Okay? Now, moving right along, right? All right, so today we're going to talk about factoring factoring expressions. So we've used the distributive property to expand expressions. So now we're going to go backwards. Okay? So I want you to look at what I have on the top of your sheet. It says, what do 2 times the quantity 3x plus 4 and 6x plus 8 have in common? Zach?
They're the same thing.
Okay, they're equivalent expressions, right? So 2 times 3x plus 4 and 6x plus 8 are equivalent. Now, how do I know that? Well, if I take 2 times 3x plus 4 and I use the distributive property, put your head down, Mrs. Thank you. I don't care, but if the boss walks in. If I use the distributive property, 2 is my coefficient, and I do 2 times 3x, which is 6x, and then 2 times 4 is positive 8. So 1 is the expansion of the other, or we could say 1 is a factor of the other. So we have worked really hard to go from here to here, right? We spent a couple of days doing the distributive property. So today we are going to learn to go from here to here, okay? And that is called factoring expression. So there's 2 steps to factoring. We're going to find the greatest common factor of our terms, and then we're going to divide out our GCF to rewrite the expression. So the one we're going to use is we're going to use 6x plus 8. Why do you think I use 6x plus 8?
Because that was like our product.
Right, we already know that, right? So if we already know that, we know easily that we should get back to here. Okay, so we should get back to 2 times the quantity 3x plus 4. So I'm going to find the GCF of my terms. So I'm going to focus on the 6 and 8. So I already see Craig has his hand up, but we're going to go through the steps just in case we have numbers that we don't already automatically know the GCF of, right? So 6 breaks down into 2 and 3. And then 8 breaks down into 2 and 4 and 2 and 2.
Easy peasy lemon squeezy.
Okay, so for 6 we have 2 times 3. And for 8 we have 2 times 2 times 2.
Times x. 2 times
Okay.
3 times x.
Okay. There you go. I kept on forgetting it last week. All right. Brody, sorry.
There's 2 that's common.
Very good. We have a 2 that's common. Do we have anything else in common?
No.
No. So our GCF of 6x and 8 is 2. So 6x plus 8. What do we have in common? 2. So our 2 comes out front.
And then what do we...
Now we divide out our GCF. So I divide by 2. 6x divided by 2
3.
is 3x. And then 8 divided by 2
4.
is 4.
Whoa. Whoa.
That makes a lot of sense.
That's
Oh, so we divide this
that makes sense. But that's like weird.
Mm-hmm. Isn't that weird how that works?
That's like trippy.
Yeah. Okay. Okay?
That's why I don't like it.
So here's our answer. So again, we found the GCF. And then we divided out the GCF and rewrote our expression.
Switch work
Okay.
backwards.
So our GCF all becomes our coefficient, and then each term is divided by our GCF. Okay? All right, let's practice. Okay, 5x plus 30. What do I do first?
Divide 5x and by 30x.
Nope.
You can't. No, you have to GCF.
We have to find the GCF. Okay? What kind of number is 5?
Number.
It's prime. Do I have to find the GCF? Do I have to break down 5 any further?
No.
No, I don't have to break down 5 any further. Because I know that 5x is just 5 times x. 5 doesn't get broken down any further than just 5. So I find the of 30. What are my factors of 30? How do I break down 30? Brooke?
10 times 3.
Okay, you do 10 times 3. What else could you use? 6 times 5. 2 and 15, very good. Okay, any of those work, right? Tucker, what are you going to do?
The 5's in common.
Very good, we have a 5 in common. So what does that mean?
I mean that's our GCF.
Very good. Our GCF is 5. Okay. So if our GCF is 5, 5x plus 30,
Divide that by 5.
okay, our GCF comes out in front. 5x divided by 5, 1 what?
X.
30 divided by 5,
6.
how can I check to know if I was right?
Calculator.
Just do the original form.
Right, could I go back into the distributive property to check to see if I'm right?
Yeah.
Yeah, I could do 5 times x, 5x, 5 times 6, 30. So the great thing about factoring expressions is I can always go back. I can go back and see if I was right, okay? It's an awesome thing when you can go back and check your answer, right? Instead of just writing something down on a piece on your test and be like, that's good enough, right? If you take your time and go back and check, if you have that ability, use that time, right? How long are your quizzes or your tests in here? Right? Not very long. Do you have time that you could utilize to go back and check your answers? Absolutely. Okay. All right. What do you notice about this one? Okay, there's a negative, right? 8x minus 6. Does that change our course? No, it doesn't change our course. Okay? So what we know that inside the parentheses we're going to have what kind of sign? A negative or subtraction, right? And that's okay. All right, so we already know the GCF, don't we?
Yep.
Didn't we already do the GCF of 6 and 8?
Yeah.
So what's our GCF?
2.
2. If you know the GCF, do you have to do the whole thing? No, you don't. Okay? If you can look at 5 and 30 and know the greatest common factor is 5, do you gotta do all this, Jazz?
No.
No. Is it a good tool if you have larger numbers and you don't know the GCF? Absolutely. Okay? So if our GCF is 2, where does 2 go?
On the outside.
Very good. It goes in the front of your parentheses.
Did I just do it right? If I get this right, I would be so stoked.
Now what do we do?
Then you gotta.
Zach?
And then you have to do 2 times 4x.
So I divide, right?
Yeah.
So both my terms get divided by the GCF. 8 divided by 2? 6 divided by 2?
No way!
Okay.
So basically, it's the same thing, but instead of the 3 having the x, it's the 4.
Because I just flip-flop my term.
So I know what the green comes.
All right, number 3.
Should you just leave it the same?
Okay, Tucker wants to just leave it the same.
Because 3 is a prime number.
Okay, 3 is a prime number.
Just by using the method.
4 is not.
4 is not.
4 is 2 times 2. 3 already.
So greatest common factor would be like 1.
So what's your greatest common factor?
There isn't. Well, actually, technically there is.
Look at 2, 2, 3, and 1. Is there a greatest common factor?
No.
What is the greatest common factor?
Nothing. 0.
Not 0.
1.
1.
Oh, yeah, because they both
Four
can be
times one.
Okay.
multiplied by
So even though, okay, you got to think about it. Is there a greatest common factor between 4x and 3?
Yes,
1.
1.
There's 1, but what can we do with 1?
Nothing.
Nothing. So what do we know about 4x plus 3? It's already factored. Okay, you can't go any further.
Oh.
And there are times that you're given problems that you can't go any further. Okay? So all we have to say is already factored. When there is no GCF between the terms, it's already factored. Okay? Now, when I say no GCF, I actually mean that the GCF is 1. Okay? Because every set of terms has a factor of 1. But that doesn't do us any good. When you factor out 1, you just get the same number. You can do that all day long, and you're going to continue to get the same number, same term. So why waste your time, right? I usually tell you on your test how many cannot be factored, so that you know, so you're not saying, oh, can't be factored, can't be factored, can't be factored. You're just writing that all over the place, right? I want to trick you. Right. All right, let's look at number 4. What do you see?
There's a squared. X squared. 18x squared.
Okay, 18x squared minus 4x. Okay, so what?
There's a negative.
Okay, and there's a subtraction sign. Yep, absolutely. They both have a variable. Very good. One's x squared and one's x. Okay. Does our course change? No, our course doesn't change. Okay? We're going to have to take a little bit more detail, and we're going to be a little bit more focused on our exponents. But our action doesn't change. We did this all day on Friday. We're just going to apply it to our problems today. Okay? So, we need to start with 18 and 4. Okay. Factors of 18.
9 and 2.
Okay, 9 and 2. What else could I use?
6 and 3.
6 and 3. Okay. Okay, what's next? Factors of 4?
2 and 2. 3 and 2.
So after we did this step yesterday, what did we do? Or not yesterday, but on Friday, what did we do next?
We did our.
You have to sort the variables.
You gotta do your variables, right? So if I have 18x squared,
It would be
X times X.
x times x.
2 times 3 times 3 times x times x. And then what does 4x look like?
2 times 2 times x.
Oh, what'd I do?
Oh,
2 times
it's
2.
2.
I'm like, the greatest common factor. 4 is not a factor of 18. Zach,
Interesting.
yeah, come on.
Oh, your phone did
Pause.
paused again.
Your phone dies, cut it. Sing. Shit.
What do I have in common?
2x. So, 10 is 2x.
Okay, so what does that mean?
That the greatest common factor is 2x.
Very good. Our GCF is 2x. So Brody just said, if I have 18, let me extend my page here, guys.
You're extending now.
Okay. If I have 18x squared minus 4 plus 4x or minus 4x? Minus, okay, here we go. So I have 2x in front. So 18x squared is going to be divided by 2x.
So that would be 9x.
Okay, so 18 divided by 2 is 9. X squared divided by x
Is x.
is just x. Okay, because we took one x out, so we have one x left.
So then it would be minus. It would be minus.
So 4 divided by 2,
Is 2. That would be 2.
x divided by x,
0.
0. Okay, so do we need it?
No.
No. If I am taking an x out, do I have an x left?
No.
No. So I'm done. How are we feeling?
Good.
All right. What do you see about number 5?
That there's an x and a y.
Okay, there's an x and a y.
And squared.
Okay, and they're both squared. Do our variables have anything in common?
No. So it's just.
Our variables don't have anything in common. We've got x squared and y squared. Are we going to have to factor our variables? We're not going to have to factor our variables because they have nothing in common. If you can see right away that they have nothing in common, do you have to do that part of the work?
No.
Absolutely not. Okay? You don't want to take, you don't want to worry about something that you don't have to worry about, right? So, what is the only thing in this problem we have to worry about? The 20 and the 4. I really liked 4 today, didn't I?
Yeah.
I had to get my blood drawn this morning,
Oh.
and I rushed up here and I was like, oh, shnikes. Sorry. Okay, what do you know about 20? 5 and 4?
2 and
2 and 10? Is it going to matter?
No.
Absolutely not.
It'll be the same.
Good morning.
What if that greatest common factor still be 4 though?
Okay, so your greatest common factor is
4.
4. So 4 comes out front. So once you bring your 4 up front, what do you do with 4 to help you find what goes in your parentheses?
We have 4 divided by 20 is squared.
Good?
And then 4 divided by
4 divided by 4 is 4. Oh, so you just bring
Oh, that's easy.
Just bring down your variables because you don't have to take anything out.
Yeah.
Okay? Yes, Craig.
Can we try the last one on our own?
Yeah.
Yes. Can't do it.
Go ahead and try the last one on your own. What do you know about 19 and 13?
They're prime.
They're primes.
So I'm trying to think of something like I can't.
I didn't know about 13, but
I didn't think they could be prime since there's like 2.
I think I have it.
Right? So 19 and 13 are prime. Can you do anything with it?
No.
No.
We have to use the variables.
Okay? But look at our variables. What do you know about our variables?
They're the same.
They're the same. So what are we going to do?
It's already factors.
We got to take we got to take what we have in common out. Okay? So what's the only thing we have in common? The x's, right? So if I look at this and I go 19x squared is equal to 19 times x, and then I have 13x squared,
Just 13x.
my GCF is x squared. So what comes out front?
X squared.
X squared.
So wouldn't you then take away the variables for 19 and 13? Then just write 19 plus 13. Oh.
That's it.
That's quite odd.
Yeah.
I wonder if it like made all this complicated stuff.
I don't know. Like, who thought of this? Some dude in Greece with his rubber on him sending us.
All right, you want good news?
Yeah. The homework?
No homework.
Imagine there. All right. Will we use this in our